All right, so let's do some examples for binomial expansion using the Pascal's triangle and everything we've done. What I want to show you is this method, because we can use literally the whole A and B equation, but using this method to me is cleaner, simpler, as long as you follow the steps. But it's up to you, whatever you want to do, because you can literally use the whole equation that we did previously and just plug in A and B and multiply it, simplify it out. Or you could use this method. So this method was actually made by a former student of the past that just made it up himself, and he shared it, and we've been using it ever since, and it's been successful. So if you guys ever know a new way to do things, then always share it. It might be better than what we do and teach you. Okay, so what you're going to do is, the first row, you have three, right? 3 rows, and just go across. If you need to make this huge, make it huge. We're going to have fourth power, so that means we're going to have 5 terms. So I'm literally going to have 5 columns going down, right? But there's always 3 rows, because the first row is going to represent your N, your next row is going to represent A, and then your 5th row is going to represent B. So my N is 4. My A is actually X, and then my B is -3. Okay? So the N row you take straight from Pascal's triangle. So if I look at my row 4, my previous notes, row 4 is going to be 1, 4, 6, 4, 1. So we have 4th power, and we have 5 terms. 1, 2, 3, 4, 5. So that makes sense, okay? The next one is X. So the way we do this and stay on top of it is that I'm kind of like zigzagging, right? I'm pretending I'm in a line for a roller coaster or something. So we're going to the left to right, then we're going to go back around, right to left, and then finish left to right. So we're doing this row here, coming back and do the A row, coming back this way and doing a B row, okay? That first row right here for A is going to be just 1 or squiggly or blank, whatever you want to make it. I don't know why the student did squiggly, and I've always used it because you guys remember it next year when you do pre-cal. Like, oh, that method with the squiggly. Yeah, Mr. Pettis taught me that. Yeah. So I use squiggly just because I've been doing it forever. But technically, if you would do it mathematically, it would be a 1, right? Because what I'm going to do is X times 1 is going to be X. So I have a squiggly or a blank, and then I just bring in my X. So a blank, and then I bring in what's on the outside. And I'm always just going to be multiplying by that outside, right? So X times X is X squared. X squared times X is X to the 3rd. X to the 3rd times X is X to the 4th. And it looks right because I am counting down my A values. I have A to the 4th is what I start with, and then I count down 3, 2, 1, nothing, right? Okay, that makes sense. So going this way, coming back around, this will be a 1 or a squiggly or a blank, and then I bring in my -3. So -3 times -3, that's 9. 9 times -3 is -27. And then -27 times -3 is 81. Positive 81, right? It's the same thing as saying -3 to the 1st power, -3 squared, -3 to the 3rd power, -3 to the 4th power. But we don't have to even write that out because we could just do the math. The last step is just going to be multiplying straight down, okay? So this is where I'm looking at my columns. 1st term, 2nd term, 3rd term, 4th term, 5th term. 5 columns. So multiply going down. That would be X to the 4th. Multiply 4 times -3. And that's -12. And you still have X cubed, right? So 6 times 9 is 54. And I still have X squared. -27 times 4 is -108, and I still have X. Then 1 times 81 is 81. And this polynomial is X minus 3 to the 4th power. Okay, so it's real nice and neat and organized. And that's what I like to do, okay? So I want you to practice that with the worksheet that you got today. So let me do one more problem before. This is actually from the worksheet from today. So if you weren't here, you don't have to do all of them by yourself. So the next one's going to be 2y minus 2 to the 5th power. Okay, so I have the 5th power, which is going to mean I have 6 terms. So I still go 3 down. I make it a little bit longer because I'm going to have 6 terms, right? So this, remember that this is your n row, a row, b row. So your n is 5, your a is 2y, and your b is actually negative 2. Okay? And remember on the side, we're going zigzag. All right, so n row. What is the 5th row of Pascal's triangle? It's going to be 1, 5, 10, 10, 5, 1. Okay, so a blank or a 1, whatever you want it to be. The first one, I'll just say 1 this time. Because 1 times 2y is my 2y. So 2y times 2y is going to be 4, because 2 times 2 is 4. And then y times y is y squared. All right, so 4 times 2 is 8. Y times y squared is y3. Okay, times 2y would be 16y4. Times 2y would be 32y5. Okay, so then this would be 1 again. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4 times negative 2, negative 8 times negative 2, positive 16, and times negative 2 would be negative 32. Okay? So, like I said, this could be a squiggly or 1, whatever you want it to be. Whatever makes sense with you, whatever makes you happy, right? Squiggly or 1, bring in the outside multiply. So what I do want to bring up, though, is the second row, the A row. Remember, it's critical. If I'm multiplying 2 terms, I am multiplying the coefficients, the big number. 2 times 2 is 4. 4 times 2 is 8. But when I'm multiplying, my exponents are actually adding. 1 exponent here plus 1 exponent is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. So multiply coefficients, add exponents when you're multiplying. That is crucial. All right, so let's finish this off. Call it a day. So each column multiply going down. So 1 times 32y5 times 1. So this is kind of why I like the 1 rather than squiggly now. I decided that today, is because the multiplication makes sense. But either way, same thing. Same. All right, so that would be 32y to the 5th. Multiply the next column going down. That's negative 160y to the 4th. Multiply the next column, 10, 8, and 4. 10 times 8 times 4 is positive 320, and I have y cubed. And then 10 times 4 times negative 8 is negative 320, y squared. 5 times 2 times 16 is going to be positive 160y. And then 1 times 1 times negative 32 is negative 32. So this polynomial is 2y minus 2 to the 5th power in standard form. All right, guys and girls. Hope you enjoyed this. Hope you got something out of it. I enjoyed today's class. If you weren't here, you missed a great time. But we'll see you tomorrow. Have a great day.